Good morning, children. In maths, every lesson is a continuation of or an extension of the concepts you have learned in the previous classes. Let us move on to chapter 3, linear equation in two variable. What is an equation? If you take an example of 7 plus 3 and a number 10, what is the relation between 7 plus 3 and 10 is 7 plus 3 is equal to 10, which shows that an equation means it is a statement of equality. A statement of equality. So what is the meaning of an equation is a statement of equality which proves that if you have an equation, there is a left hand side and a right hand side, and we used to denote them as LHS and RHS. What are the two variables? The variables you can assume as X or Y, U and V, A, B, any letters in the English alphabet. Linear equation. The term linear is denoted in such a way that the power of the variable you are assuming should be only 1. Thus, the general form of a linear equation in two variable is ax plus by equal to c, where a and b should not be 0. At the same time, the values of a, b and c should be in the real number system. The general form of ax plus by is equal to c. Now, the examples of linear equation are 2x minus 3y is equal to 8, square root of 5x minus 6 by 7y equal to 12. These are all the examples of linear equation in two variable. The next topic is what is the graph of a linear equation in two variable. The graph will always be a straight line. What is the solution for a linear equation is the ordered pair xy in the coordinate system which will satisfy the given equation. The meaning is what value of x and y you will substitute in the equation so that the left hand side balances with the right hand side. By plotting the points in the graph, 8, 0 will give you the first point. 8, 0 is the point on the x-axis. The second point, 9, 1, 9, 1 is approximately here. And the third point is 7 minus 1. 7 minus 1. If you join these 3 points, you will get a straight line. Passing through these points, this is the graph representing the equation x minus y is equal to 8. You can see that the straight line passes through many points in the graph, which proves that there are many solutions for this particular line. Thus, what is the meaning of solution of a linear equation? From here, what is the meaning of solution of a linear equation? The solution of the linear equation is that ordered pair xy which satisfies the given equation, which proves that the points 8, 0, the points 9, 1, the points 7, minus 1, these are the 3 points we considered, but there are infinite points on this line which satisfies the equation x minus y is equal to 8. After knowing the concept of a linear equation in two variables, what is the meaning of pair of linear equations? What's the meaning of pair? It means that there are two equations given to you. Can you tell me what can be the general form of this pair of linear equations? You have taken the general form as ax plus by equal to c. Just replace the value of a, b and c with a1, b1, c1 in the first equation and a2, b2, c2 in the second equation and try. Thus, what is the general form of a pair of linear equations? The general form is a1x plus b1y equal to c1 and a2x plus b2y equal to c2. The conditions remain the same, that is a1, a2, b1, b2 should not be 0. At the same time, a1, a2, b1, b2, c1 and c2 all are real numbers. So, the general form of a pair of linear equation is a1x plus b1y equal to c1, a2x plus b2y is equal to c2. Let us discuss about the graph of this pair of equation. The graph of a pair of linear equation will be two straight lines which will be plotted in the coordinate system. What is the meaning of solution of this pair of linear equation? The solution of, it's a pair of linear equation, so the solution of this pair of equation is the values of x and y which satisfies both the equations at the same time. So, once again, the solution of a pair of linear equation is an ordered pair xy which satisfies both the equations at the same time. That is, the general form of a pair of linear equations is a1x plus b1y equal to c1, a2x plus b2y is equal to c2. The graph of a pair of linear equations will be straight line. The solution of a pair of linear equation is that ordered pair xy which satisfies both the equations at the same time. What are the possibilities when you draw the graph of two linear equations in the same graph paper? The first possibility is the lines may intersect at a point. The second possibility is the lines do not intersect or they represent parallel lines. And the third possibility is both the lines are coincident, which proves that the lines both represent in a single graph. The three possibilities are the lines may intersect in one point, the lines do not intersect, and both the lines will represent a single straight line. From these graphs, what can you infer about the solution of a pair of linear equations? When the lines intersect at one point, it is very obvious that they have only one solution. Only a single ordered pair xy will be a solution for this pair of linear equations. When two lines are parallel, there is no solution possible for the pair of linear equations, and if the lines are coincident, there are infinitely many solutions. So in brief, a pair of linear equations a1x plus b1y equal to c1 and a2x plus b2y equal to c2 can have number one, unique solution or one solution if the lines are intersecting. The equations can have no solution if the lines are parallel, and the equations will have infinitely many solutions when the lines are coincident. And when a pair of equations is given to you, how do you know what type of solutions exist? We will go in detail into that after drawing the graph, and I will explain the conditions. Draw the graph of the pair of linear equations x minus 2y equal to 0, 3x plus 4y is equal to 20. The calculation: x minus 2y equal to 0, x is equal to 2y. The three values of y can be 0, 1, minus 1. X value is 2 into 0 is 0. X is equal to 2 and x is equal to minus 2. The tabular form: x and y, 0, 0, 2, 1, minus 2, minus 1. The calculation is simple in this case. The second equation: 3x plus 4y is equal to 20. 3x is equal to 20 minus 4y. X is equal to 20 minus 4y by 3. The method is: give values for y in the order of 0, 1, minus 1, 2, minus 2, etc. till you get whole number, because whole numbers are easy to plot in the graph paper. I can explain an easy method after getting the first point. The first point is by trial and error. You give the value of y as 0. 4 into 0 is 0. 20 by 3 is a fraction. Avoid it. When y is equal to 1, 20 minus 4 into 1 is 4. 16 by 3 is again a fraction. If you give y as minus 1, 20 minus 4 into minus 1 is minus 4. 20 plus 4, 24 by 3 is 8. If y is equal to minus 1, x is equal to 20 plus 4 by 3, which is giving you 8. The next value, by easy way, you can calculate as minus 1 plus 3. Minus 1 plus 3 is positive 2. Third value, minus 1 minus 3. y is equal to minus 4. That is, after getting the first value, you can add with the denominator, you can subtract with the denominator. Definitely those values of y will give you a whole number. X is equal to 20 minus 4 into 2 by 3, 20 minus 8 by 3, 12 by 3 is equal to 4. X is equal to 20 minus 4 into minus 4 by 3, 20 plus 16 by 3, 36 by 3 is equal to 12. Thus, the points are x, y. The points are 8 minus 1, then 4, 2 and 12 minus 4. Let us plot in the graph and see 0, 0 is the point, 0, 0, 2, 1, positive 2, 1 and minus 2, minus 1, minus 2, minus 1. You can see it's a straight line covering all the 3 points. When you draw in the graph paper, please make sure you are writing the points where you are plotting. Next, the points 8 minus 1, 8 minus 1, 4, 2, 4, positive 2 and 12 minus 4 and 12 minus 4, 12 minus 4, even with a rough diagram, you can make out that the lines intersect at exactly one point, which shows that this pair of linear equation has only one solution. From the figure, you can understand that the lines will be intersecting and the solution will be the coordinate of this intersecting point. Take the second example. X plus 2y is equal to 4 and 2x plus 4y is equal to 12. Let us get the points. X plus 2y equal to 4. X is equal to 4 minus 2y. If you can give y as positive values, then numbers will be smaller. Let y is equal to 0, 1 and 2. X is equal to 4 minus 2 into 0, which is equal to 4. X is equal to 4 minus 2 into 1, 4 minus 2 is 2. X is equal to 4 minus 2 into 2 or 0. The table formed as xy, first value of 4, 0, 2, 1, third value of 0, 2. The second calculation of 2x plus 4y is equal to 12. Please listen carefully. 2x is equal to 12 minus 4y. X is equal to 12 minus 4y by 2. By trial and error, get one value of y. If you try y is equal to 0, 12 by 2, 6 is a whole number. For y equal to 0, the x is equal to 12 by 2, which is equal to 6. The next value is 0 plus 2, which is equal to 2. As I told you, if you go with a positive value, the next value can be 2 plus 2, y as 4. This is an easy method of getting the points fast, or those who can't, please substitute the values as in a trial and error method. X is equal to 4 2s are 8, 12 minus 8 is 4, 4 by 2 is 2. If you substitute y as 4, 4 4s are 16, 12 minus 16 is minus 4. Minus 4 by 2 is minus 2. Thus, the points formed as 6, 0, 2, 2 and minus 2, 4. By plotting the points 4, 0, 2, 1, 0, 2, 4, 0, 2, 1, 0, 2 and 6, 0, 2, 2 and minus 2, 4, 6, 0, 2, 2 and minus 2, 4. If you join the points, the first line the second line, you can see that the graph is representing parallel lines. Thus the equation is x plus 2y is equal to 4 and 2x plus 4y is equal to 12. Consider the third pair of linear equations. 2x plus 3y is equal to 9. 4x plus 6y is equal to 18. 2x plus 3y is equal to 9. 2x is equal to 9 minus 3y. X is equal to 9 minus 3y by 2. By these calculations, you can learn the next topic also, the solution by graph. Y equal to any value of y which gives you as a whole number. Y equal to 0, 9 by 2 is 4.5. When y is equal to 1, 3 into 9, 6. Now y is equal to 1, 9 minus 3 is 6, 6 by 2 is whole number. When y is equal to 1, x is equal to 9 minus 3, 6 by 2 which is equal to 3. As I told you, 1 plus 2 is giving you y is equal to 3. Again, 3 plus 2 which will give you y is equal to 5. The calculation x is equal to 3 3s are 9. 9 minus 9 0. So the value of x is equal to 0. 3 5s are 15. 9 minus 15 is minus 6. Minus 6 by 2 is minus 3. X is equal to minus 3. Thus the points are x, y, 3, 1, 0, 3, minus 3, 5. The second set, 4x plus 6y is equal to 18. 4x is equal to 18 minus 6y. X is equal to 18 minus 6y by 4. Giving the value of y as 0, 18 by 4 is not a whole number. 1, when value of y is equal to 1, 18 minus 6, 6 into 1 is 6, 18 minus 6 is 12, 12 by 4 is 3, x is equal to 3. Let's take the value of 1 plus 4, 5, x is equal to, you can calculate 6 5s are 30. 18 minus 30 is minus 12. Minus 12 by 4 is minus 3. Next value of 5 plus 4, 9. 6 9s are 54. 54 minus 18 is 36. 36 by 4 is 9 with a negative 9. Thus the values are 3 1, minus 3 5 and minus 9 9. Let's plot the values. 3 1, 3 1, 0 3, 0 3 and minus 3 5, minus 3, minus 3 5. The next equation, 3 1, minus 3 5, minus 3 5 and minus 9 9. Minus 9 with minus 9 with 9. Both the lines, when you plot in the single graph paper, they are coincident lines. So what are the example? There are infinite solution. The equation is 2x plus 3y equal to 9 and 4x plus 6y is equal to 18. We can have a brief of the points discussed till now from the details given here. The general form of a pair of linear equations, the graph of a pair of linear equations, what is the meaning of solution, what type of solutions, unique solution when the lines are intersecting, no solution when the lines are parallel, and infinitely many solution when the lines are coincident. By these derivations, we can find out what is the criteria for the consistency of a pair of linear equation. What is the meaning of consistency is whether a pair of linear equations have solution or not. By taking the examples, the first pair x minus 2y is equal to 0 and 3x plus 4y is equal to 20, and this pair of linear equation gave you a pair of intersecting lines which shows that the equations have a unique solution. Let's compare the values of a1, a2, b1, b2 and c1, c2 with the general form. The coefficient of x will give you a1 and a2. The coefficient of y gives you b1 and b2, and the constant is giving you c1 and c2. So the value of a1 is 1, a2 is 3, b1 is minus 2 and b2 is 4, c1 is 0 and c2 is 20. When you look at the values, we can derive a condition between a1, a2, b1 and b2. The ratio a1 by a2 is 1 by 3 and the ratio b1 by b2 is minus 2 by 4. They are not equal. a1 by a2 is 1 by 3 and b1 by b2 is minus 2 by 4 is the same as minus 1 by 2. Here there is no equality among the ratios of a1 by a2 and b1 by b2, that is a1 by a2 not equal to b1 by b2 will determine the lines as intersecting lines and the solution as unique solution. Thus, given two equations to you, just compare the value of a1 by a2, b1 by b2. If the ratios are not equal, you can infer that the graph will be intersecting lines and the equations will have a unique solution. Consider case 2. X plus 2y is equal to 4. 2x plus 4y equal to 12. The same way, compare the values of a1 by a2, b1 by b2 and c1 by c2, which will give you a relation. a1 by a2 here is 1 by 2. b1 by b2 here is 2 by 4, which is the same as 1 by 2. The value of c1 by c2 is 4 by 12, which is equal to 1 by 3. And the lines were parallel and there was no solution. So what is the condition for the lines to be parallel and for no solution is a1 by a2 ratio and b1 by b2 ratios will be equal, but those two ratios will not be equal to c1 by c2 and the lines will be parallel lines and there will not be solution, which proves that there is no value of x and y possible satisfying both the equations at the same time. Taking the third pair, 3y is equal to 9, 4x plus 6y is equal to 18. Compare the values of the ratios. A1 by A2 gives you 2 by 4, 1 by 2. B1 by B2 is equal to 3 by 6, 1 by 2. C1 by C2 is equal to 9 by 18, 1 by 2, which proves that all the three ratios are equal. Therefore, if A1 by A2 is equal to B1 by B2 equal to C1 by C2, the lines are coincident and the equations will have infinitely many solutions. So this is the condition by which you can understand whether a given pair of linear equations have unique solution, many solution, or they do not have a solution. And what is the meaning of the word consistency? If there is a solution, the equations are said to be consistent. So, when A1 by A2 not equal to B1 by B2, the equations have unique solution. Thus, we use the word the system of equations is consistent. That means for consistency, the condition should be A1 by A2 not equal to B1 by B2. So, if there is no solution, we say the system is inconsistent. For the condition for inconsistency is A1 by A2 equal to B1 by B2 but not equal to C1 by C2. So what will you say for the equations having infinite solution is the system is dependent. They are consistent as well as dependent and consistent. That means there are many values and at the same time all values are dependent on each other. So the system of equations which have the values A1 by A2 equal to B1 by B2 equal to C1 by C2, you can say that they are consistent and dependent.